Hey, fifth grade. Today we're going to be doing module 4 for lesson 10. And what I would like you to do for this lesson, if you would like to do these on your desk, that is fine. But something I would like you to write in your math notebooks is just this example I have right up here that shows sum, difference, product, and quotient, because this is going to be important to understand for this lesson. So I have 1 plus 2 equals 3. And I have sum next to that. 2 minus 1 equals 1. That is difference. 2 times 2, which equals 4. That is your product. And then 4 divided by 2, which equals 2. And that is called your quotient. So the answers to all these different problems have different definitions basically that go along with them, or terms, based on the type of math you had to do to get that answer. So if you're adding, it's the sum. If you're subtracting, it's the difference. If you're multiplying, that's a product. And if you're dividing, that's a quotient. So just for you to know. So please get that written down somewhere for safekeeping for this lesson. Now, for this lesson, we're going to be doing a lot of different things. So this might be another lesson where you might want to have a notebook to write everything down in, because we're going to be doing expressions and comparing and contrasting expressions, doing tape diagrams, and a lot of different things. So you're going to want to keep track of everything that we're doing. So for the first problem, what we're going to be doing is we're going to be looking at tape diagrams, and we're going to be writing an expression to show how to get the answer for this tape diagram. Because right now, I have something weird up here. I have 9 plus 11, and you might not know how to solve a problem that has 9 plus 11 up there like that. So in order to do that, I'm going to be writing a number sentence, and I'm going to figure out how to write that number sentence by looking at my model. And I'm going to kind of give you step by step how to do this, and then we're going to be doing another one after this. So the first step in doing this problem is I want to identify what my whole is. So in this situation, my whole is 9 plus 11. The reason why this is my whole is because this is what my whole tape diagram is equal to. So my whole is 9 plus 11, so I'm going to write that off to the side. I'm not going to put anything else next to it just yet. We're just going to write 9 plus 11, and I would like you to do that as well. Now, what I am doing is I'm going to write a number sentence, because I still need to figure out what this question mark is. And how I'm going to figure out that question mark is I need to figure out, well, what fraction of 9 plus 11 am I looking at? So, since I use what fraction of 9 plus 11, that lets me know that I'm going to be multiplying, because remember, if I'm trying to find groups of or a fraction of, that is multiplying. So whenever I say of, that usually means I am multiplying. So right now I have multiplied or times 9 plus 11. Let's figure out now what fraction is going to go up in front of that. And so what I do is I look at this section that I'm trying to find the question mark for. And I'm thinking of, all right, well, how many total parts is this tape diagram made up of first? And when I look at this tape diagram, I see that there's 1, 2, 3, 4 different parts it's made up of. So that is my denominator. And now I'm trying to figure out, well, how many parts am I trying to find of this tape diagram, or of 9 plus 11? Well, I'm not trying to find the whole thing. I'm only trying to find 1, 2, 3 out of the 4 parts. So I'm only trying to find 3/4 of, or times, 9 plus 11. And now that I have a problem like this, I can actually start solving this. Now, this might be a little bit confusing because you have more than one type of math in a problem. It's not just adding or multiplying. It's now all together. And you might freak out and say, I have no idea how to do this. But that is what we're going to learn about this lesson. So another thing that I want you to write down, in addition to this, and you might want to put this in your notebook, is this really useful acronym that's going to help you remember the order of operations. So we're going to write that down. Order of operations. And the order of operations tells me the order I have to do my math in. Because if you were to just look at this problem, you might not know where to start. Do I start with 3/4 times 9? Do I start with 9 plus 11? What do I do? So the order of operations tells me what to do first. So in this section, I will start with, please excuse my dear Aunt Sally. And each of these letters in this acronym give me a step that I need to do. So for the first one, P stands for parentheses. And this is where I do all the math that's inside of the parentheses. E stands for exponent. We don't have to worry about those in this lesson, so still write it down, but you're not going to have to worry about it for this lesson. M is for multiply. That is definitely something you're going to see. D is for divide. That is another part you will see in this lesson. A is for add, and S is for subtract. So please take a minute and get all of these down right now and make sure you label it as your order of operations. So get that done. Now, when I was setting up this problem, something that would help me figure out where I need to start is if I put parentheses around this section right here. And you might ask, well, why did you put parentheses around this part and not around maybe 3/4 times 9? And the reason I didn't do that is because this 9 plus 11 was already together before I started the problem. This 3/4 times 9 part, that wasn't together yet. But 9 plus 11, that's been together from the start. So I'm going to put parentheses around that. And now we're going to start to try and solve this problem. So I'm going to look at my order of operations, and I'm going to think about, all right, what is my first step? And I'm going to take a look at the first step, which is parentheses. Look at my expression and think about, do I have anything that's in parentheses? If you do, then that's the kind of math that you will start with. So I look at my parentheses and I think, okay, I'm going to start with that. So I'm going to do 9 plus 11, which is 20. And now my parentheses disappear because I used them up. And I'll rewrite that 3/4 times 20. And I got 20 because I did 9 plus 11. Now I keep moving down until I find my next order of operations. So I don't have any exponents, but I do have to multiply. So now I need to set up 3 times 20 over 4. So just like we did in the previous lesson, we're going to do 3 times 20 over 4 like this. And I'm going to use that cross out, like simplifying method, because that helps me the most. So I'm going to cross out 20, cross out 4, and I'm going to divide both of these by 4. And 4 divided by 4 is just 1. 20 divided by 4 is 5, which will then give me 3 times 5, which gives me 15 as my final answer. So this part is something you already know how to do. Even this part is something you know how to do. So what's new for this lesson is you're taking a look at these tape diagrams, you're making an expression like a number sentence out of it to help you figure out what you're trying to solve for, so you can figure out this question mark right here, and then you can do the math from there. So that is the point of this lesson. I'm going to pause the video to get our next tape diagram up. Please make sure you have all of these notes on your in your notebook already. And 1 second. All right, so I have our next problem up. And this one's a little bit trickier because we're going to switch things up just a wee bit. And for this problem, normally, like I told you last time, you would want to start with the whole, and you would use that to start off your expression. But in this case, I don't know what my whole tape diagram equals to yet. All I know from this tape diagram is that one section equals a third minus a fourth. And that really doesn't help me figure out what my whole equals, or even that might be difficult for me to understand what one section equals. And normally, if you were doing tape diagrams from a few lessons ago, like lesson 6 or 7, if you had a number here, like maybe 2, and you're trying to figure out what the whole tape diagram equals, normally you would take this number and multiply it by the number of boxes to get the entire tape diagram's amounts. And in this case, we're going to be doing something very, very similar. What I'm going to be doing is I'm going to be multiplying this third and minus a fourth by 5. So I'm going to be doing 5 times 1/3 minus 1/4. And the reason why I'm multiplying this by 5 is because there are 1, 2, 3, 4, 5 boxes. So I have 5 units and I need to multiply all 5 by this third minus a fourth. And before I continue, what I need to do is I need to put parentheses around a third minus a fourth, because remember, these started out together. So if these started out together before I even started working on the math for this problem, I need to keep them together. Kind of think of them like a family. You can't split them up just yet. So I have to keep them together. Now my first step is I am going to have to figure out what is a third minus a fourth. So going back to module 3 now, I'm going to have to do some multiplication. And for that, I'm going to have 4/12 minus 3/12. If you need to, you can kind of cross multiply if you just want to do it like that, or you could do off to the sides the full like multiplying by the factors and things like that. You can go back to your module 3 notes to help you with this section, but you should know how to do this by now. And now we have 4/12 minus 3/12 left over, which 4 minus 3 would give me 1/12 then. And now what I need to do is I need to multiply this by 5. And now we should know how to do the problem from here. And when I get to this part, I now need to write this to get like all together like we've been learning how to do in the previous lesson. So I'm going to have 5 times 1 on the top, all over 12. Now this is where our problems are finally starting to get a little bit different, because normally I would look at this 12 and think about, okay, can any of my factors on top be divided by 12? But they can't actually. So what I'm going to do is I'm just going to multiply 5 times 1, which gives me 5, and I'll keep my denominator the same, and my final answer is going to be 5/12. So this question mark right here is actually going to change to 5/12, because that tells me that my whole tape diagram is equal to that, and one part of it is technically 1/12. And that's all we had to do for this problem. So just to recap what we did with this one, we didn't have the whole, so we had to start with a part and multiply it by the amount of units so that we could get the whole, and we made up this problem so that I could figure out what the whole thing equals. So it's kind of like using skills you already know, just with more difficult problems. I'm going to pause the video and get our next problem set up. All right, so 5th grade, what we're going to be doing now is we're going to be kind of switching gears. We're still technically doing the same thing, but it's a different way of doing it. So what I have right here is the word form of an expression. So remember back when we were learning about decimals and other things like that, we talked about word form. So when I wrote out my problem with all my numbers, that's like the numerical way of showing it. But if I write it out with a sentence using words, that is called word form. So for example, that last problem we just did, if I were to write the expression that I created, that 5 times a third minus a fourth, that was the numerical expression that I created from the tape diagram. I could have also shown this in word form as a sentence by saying 5 times the difference of a third and a fourth. And I do that by showing 5 times the difference, and that's why this was important earlier, because if you are dividing, the answer between a division problem is difference. And then we would just list the fractions or numbers that we were subtracting. So I have a third and a fourth. So again, I did 5 times the difference, because I'm subtracting, a third and a fourth. So let's take a look at this problem right here. So this one, we have to create a numerical expression from this so that we can then solve it. So what this is telling me is that I have the product of 4 and 2 divided by 3. So I'm going to look at my chart up here, and I'm going to think about, okay, which one shows me product? Well, this one shows me product, and it says that the product is made by multiplying. So I know that I have to multiply two numbers together. What two numbers am I multiplying together? Well, it says the product of 4 and 2. So that means that I'm going to be multiplying 4 and 2. So I'm going to set up that. And then it says divided by 3. So really that's easy. You know how to write a division problem. So I just write a division problem right there. And voila, I have my answer. So that is all we really had to do for creating our expression. So technically this right here and this right here are showing me the exact same problem. It's just a different way of showing it. And that's a lot of what our math is doing. We have two different ways of looking at something, but they still will give us the same answer. So now to solve this, I'm going to follow my order of operations. So I'm going to think, do I have any parentheses? No, and I didn't put parentheses because nothing was really grouped together from the start. Exponents, no. Multiplication, yes, I do need to multiply. What do I need to multiply? 4 and 2, which will give me 8. And then I have 8 divided by 3 left. And now that I have this divide step, I need to do that. So I can think of 8 divided by 3 as 8 over 3. And then you could set up a standard algorithm for that if you would like. So we can do 8 divided by 3, then 2, 6, 2. So then my final answer would be 2 and 2/3. So we were able to get all of this work just from this little sentence right here. And we're going to keep practicing this so we can work on working from sentences to math to the final answer. I'm going to pause the video so we can get our next question up, but I would like you to really write this down somewhere in your notebook and just write like word form or something next to it so you remember what this is supposed to be. All right, and there we go. So 5th grade, this is going to be our last part today for this lesson. So we're going to be comparing some different types of expressions. So far, we have learned about numerical expressions, and we've learned about like word form expressions. So what we're going to be doing is we're going to look at two different expressions, and we're going to compare them. So is this 1/8, the sum of 6 and 14, greater than, less than, or equal to 6 plus 14 divided by 8? And to show you what this all means, I'm going to be drawing two different like tape diagrams to show you the difference between these two. So let me erase this. I have some room. And what I'm going to do is I'm going to draw a tape diagram for this first problem. So I have 1/8 the sum of 6 and 14. So I know if I'm finding 1/8 of something, that means that my whole is this 6 plus 14 because I have the sum. So remember, that means that we're adding. So I know that my whole is 6 plus 14. And I know that my tape diagram should be split into 8s because I have a denominator of 8 right there. So I have 2, 3, 4, 5, 6, 7. And I've split everything into 8s. And I'm just trying to find this 1/8. So we're going to stop that there. So that is like the tape diagram for this one. Now for this one right here, we have 6 plus 14 divided by 8. So again, my tape diagram is going to be divided by 8. So 1, 2, 3, 4, 5, 6, 7. And I know that my whole thing equals 6 plus 14. And again, I am just trying to solve from there to figure out what one part would equal. So when I'm looking at these, I am actually finding the same thing. So these two expressions are actually equal because both of them, I am adding the sum of 6 and 14. So that's a big clue to us right there. And then since I'm trying to find 1/8 of that sum, and this one's being divided by 8, I'm still trying to find 1/8, just different ways of looking at it, of both of the sums of 6 and 14. So these two problems are equal to each other. So I'm going to pause real quick again and get up our next set of expressions. If you want to, please write this down because you will be doing a lot of comparing and contrasting later on in the problem set and the homework set. So there. All right, so we're going to be comparing and contrasting 4 times 8/3 versus 4 times the quotient of 3 and 8. Now, what we're trying to do eventually with these expressions is without even having to draw tape diagrams or draw the expression or figure out the answer, we just want to be able to look at the two expressions that are given to us and just kind of figure out from there if one side is greater or less than the other. And you might think this is really difficult, but there's a lot of clues that you can use within the expressions to help you out with this. So for example, when I look at this, I notice that both of these expressions are being multiplied by 4. So I have 4 times and I have 4 times. So that tells me that that part is going to stay the same. Nothing is changing there. But where things do change is my fraction. So this right here, I have 8/3, or the quotient of 8 and 3. While over here, I have 4 times the quotient of 3 and 8. And when we say the quotient of 3 and 8, that means I am doing 3 divided by 8. Because if I were to find like the quotient of 4 and 2, that means I'm just setting up a division problem. So 3 and 8 like that, so the quotient of 3 and 8, I could also write that as a fraction number, just like this, 3/8 or 3/8. Now, when you're thinking about multiplication, which number would probably give you a bigger answer? Would doing 4 times 8/3 give you a bigger answer, or 4 times 3/8? Well, if you chose 4 times 8/3, you would be correct because that is the bigger number. So that would be giving you a larger answer. So in this case, 4 times 8/3 is the correct answer. So you want to make sure you're being careful and paying attention to the order of the numbers. Don't just assume that because this answer or this expression has 4, 3, and 8, that they are the exact same thing. So sometimes they will be different. I'm going to pause the video for our last problem for today, and then I'll show you what your homework and problems that are going to be for today. All right, so for our last problem today, again, we will be doing our compare and contrast between two different expressions. So for this problem right here, what I'm going to be doing is I have subtract 2 from half of 9, and then 11 divided by 2 minus 2. So while you're looking at these problems, I want you to think about what are the similarities between these two problems. And when you're thinking of that, you may notice that these are both being subtracted by 2. So at some points, we're going to be subtracting 2 from these problems. So that might tell me that my answers might be the same from there, or they might be different. And then I'm seeing that they're from half of 9 or 11 divided by 2. Now, when I think of this, if I were to find half of 9 versus 11 divided by 2, I might get some different answers. So like this one, that 11 divided by 2, that would look like that, 11/2. If I were to find half of 9, that would look like this, 9 divided by 2. Now, which one do you think would give the bigger answer? Well, 11 divided by 2 would give you the bigger answer because if you start with more and you're dividing it by the same amount, it's going to be bigger than the one that starts with less and then is divided in half. So right here, we would have the 11 divided by 2, subtract 2 as the larger expression. So tonight, when you do your homework, you are going to be working on a variety of different problems. So for your homework today, you're going to be working on number 1, number 2, number 3, A through D, and then number 4, A through B. There's going to be a lot of different problems. Some of them might ask you to look at a tape diagram. Some of them might ask you to look at a word form of an expression and write an expression and solve from there. Some of them might ask you to compare and contrast. There's a lot of different options. But you'll also be doing your problem set in class today. And for this one, you'll be doing number 1, number 2, A through D, number 3, and number 4, A through B. So please mark down those problems and make sure you're getting that homework done. And if you need any extra help, please let me know. Thanks.